Welcome to the Webinext about carbon capture and storage, organized by both Nextcontinent and Eurogroup Consulting. Just a word about Eurogroup Consulting is a leading independent consulting firm in France with more than 500 consultants, 40 years this year. And Eurogroup is the founding citizen of Nextcontinent, international consulting network with more than 4,000 consultants today in 35 countries. Europe Consulting, through its new practice transition and its global network, Nextcontinent, through our sustainability stream, led by Sébastien, are more and more facing the decarbonization issue for their clients. Then it seems to us that it's really a new trend. And to address this decarbonization issue, we have to consider three strategic phases. The first one, before carbon emissions. This is a question of industrial strategy and business models, decision to make on how to avoid future carbon emission. The second phase is during the carbon emissions, and the key question is how to improve the industrial process. And last but not least, the third phase is after the carbon emissions. For the remaining carbon emissions, we have to consider carbon capture and storage as the last way to reduce the carbon emission. This is for us a major room for innovation to really change the scale and reach at the end the global net zero objectives. But the questions are the technologies ready? Are they efficient? And do they have a sufficient return on investment? I let the floor to our specialist, Sébastien Kahn, to present and introduce this discussion.
Thank you, François. Like you said, the decarbonization of industry will play a key role in the global energy transition, since industry is the third largest source of carbon emissions after buildings and transport, at least in Western economies. In France, for example, nearly 20% of greenhouse gas emissions are due to industry, whereas industry only accounts for 12% of French GDP. So the relative weight of industry carbon emissions compared to the financial value it brings is really high, making the decarbonization of the industry a priority. But why is industry so carbon intensive? Well, heavy industry is subject to particular constraints because although it consumes a lot of electricity, it's above all the industrial processes themselves that can be very polluting. The manufacture of plastic or chemicals from oil refining, the clinkerization of cement, and the production of steel are processes that emit really high level of greenhouse gases. That being said, a lot has been done in the past years. GHG emissions from the industry have been declining sharply over the last 30 years or so, due to process improvements and of course energy efficiency gains. But also the decline of industry in Europe and the US. So to achieve carbon neutrality for industries, the combination of three families of levers have to be activated. The first kind of lever is sobriety. So sobriety on plastic packaging, sobriety on new construction, for example, that could ensure about 20% of industry's total decarbonization path. Then the levers of continuous progress, energy efficiency or greener fuel, which could ensure 40% or so of industry's total decarbonization path. And finally, technological breakthrough levers, mainly green hydrogen and CCS, which could ensure the remaining 40% of the sector's total decarbonization path. And this last lever is our topic today. What are the different levers to activate to make the carbon industry into a mature industry quickly enough for our needs? What are the policy and the regulatory levers to boost this industry, but also the technical and financial levers? And will it be mature enough in the coming years to really contribute to the industry path to net zero? Or is it an industrial mirage, as some detractors say? And finally, what kind of transformation does it imply in organizations? So we'll have the pleasure to hear our three speakers on this matter. Dr. Helen Bray, European Policy Director for Carbon Engineering, a technology provider of direct air capture, permanent technological carbon removal technology. Welcome, Helen. Jean-Philippe Higel, Strategy and Market Director at Northern Lights, which is a joint venture between Total Energies, Shell, and Equinor, and the first company worldwide to deliver CO2 shipping and permanent storage as a service. Welcome, Jean-Philippe. And finally, Reuven Carlyle, Washington State Senator, Chair of the Senate Energy, Climate, and Technology Committee, and Principal at Point B, our US partner consulting firm. Welcome, everyone. For our participants, feel free to ask any question in the chat, and we'll try our best to answer them. I propose we begin with the discussion on the technological levers. If you're okay, so that everybody is clear on the difference between CCS and direct air capture. Jean-Philippe, maybe you can start by explaining what Northern Lights is all about and tell us if you are expecting major technological breakthrough on your side.
Sure. Good evening to everyone, and thank you, Sébastien, for welcoming me. So I'm Jean-Philippe Higel, the Strategy and Market Director for Northern Lights joint venture. And as you mentioned, Northern Lights is developing the world's first open source CO2 transport and storage infrastructure. So basically, we deliver carbon storage as a service with the aim to enable the mitigation of industrial process emissions, for which there is currently no scalable solution. So we do that to accelerate also the decarbonization of the European industry towards a net zero target set in 2050. And last but not least, to facilitate the removal of CO2 from the atmosphere, which is a concept that Helen will describe to you. So simply put, what we do is we leave the task of capturing and liquefying the CO2 emissions to the industrials, and we are taking care of the rest. So we transport the CO2 from the capture sites by ships to a terminal in Western Norway for intermediate storage, before then an export offshore by pipeline and a permanent storage in a saline aquifer, 2,600 meters under the seabed. So our transport and storage facilities will offer safe and permanent underground storage to industries across Europe. So we have taken an FID in May 2020 on the first phase of the project, thanks to the support of the Norwegian authorities. And we are currently on track to complete the construction and be ready for first injection mid-2024, so tomorrow. So we are concrete, we are building right now, and we are about to develop capacity up to 1.5 million tons of CO2 per year. But as demand from industrial sectors is growing so fast in Europe, we are actually looking to accelerating on the expansion of our capacity to over 5 million tons per year. And I'm pleased this evening to share that the European Commission has awarded us last week with a support on our FEED studies under the Connecting Europe Facility, so the CEF funding scheme. You were mentioning also that the major technological breakthrough. So quickly, I can mention maybe some elements there that we are developing right now. So first, we have started the construction of two 7,500 cubic meter newly designed liquefied CO2 carriers, a world first at this scale. And second, we will be the first ever cross-border open source CO2 transport and storage infrastructure network, with, of course, behind all the challenges related to this value chain integration.
Thank you, Jean-Philippe. What about direct air capture, Helen? Same question. Are we expecting a major breakthrough in these technologies in the coming years? And maybe you can also start by explaining a little bit what you do at Carbon Engineering.
Yeah, I'd like to share some slides if that's okay. It seems that I can't do that at the moment, so I'll just try and talk to you about what we do. So hi, I'm Helen from Carbon Engineering. We're a technology provider of direct air capture, and we capture atmospheric CO2, and we can either store that underground through the Northern Lights, as Jean-Philippe has explained, or we can combine that atmospheric carbon dioxide with clean hydrogen to make near carbon neutral fuels. And those are specifically designed for the aviation sector, where there isn't any replacement for the jet engine at the moment. So we not only provide that carbon removal, which can be stored underground, that sort of negative emissions, we also provide a solution to decarbonize the aviation sector. And we're talking about breakthroughs and technology pathways and innovation. Carbon engineering has been around since 2009. We were set up by an idea from Professor David Keith from Harvard. And his whole goal for our company is to scale direct air capture. So we have our innovation center, which is commissioning in Canada. And we also have a number of projects around the world. I'm super excited to say that we hope to start building with our partners, 1.5 in the Permian Basin in America, a 1 million ton plant per year, operational 2024. So as Jean-Philippe was saying, tomorrow. And in Europe, where it's a really growing market, we wouldn't have been talking about direct air capture 3 years ago. The only reason why we're talking about it now is because of net zero emissions targets. We have a plant in conceptual design on the west coast of Norway, very near to the point of Northern Lights where that storage goes offshore. And we have with Storegga Geotechnologies, a plant again designed around sort of 500,000 to 1 million tons. This is big scale. Again, nothing being built yet, being engineered, being studied, because as we all know, it's really important to get emissions reductions done at the same time. So accelerate emissions reduction and then find that space for that technical permanent carbon removal. Thank you, Sébastien. I'll pass back to you.
Thank you, Helen. Reuven, what's the current position of the maybe of the authorities on these technological breakthrough levers? What could you add to this?
Sure. Thank you so much, and it's a pleasure to be with everyone. I think we're living in a time where we recognize in the last 5, 6, 10 years, certainly since Paris Accord, that there's this transformational embrace of science-based net zero targets. At the same time, we have to have the humility to recognize that the marginal cost and the challenge for some of these very difficult to decarbonize sectors, like industrial sectors and of course aviation, as Helen mentioned, and sectors associated with maritime and long haul trucking and energy storage and so many others, require a creative approach that allows us to be real and authentic about the business model associated with the marginal cost. So what do I mean? I mean that we have to recognize that if we achieve 80, 90% emission reduction in some sectors, that there's going to be a marginal element of additional reductions that are necessary. And we simply can't be successful without an all hands on deck approach to both science-based targets of emission reductions and creative innovations like we're talking about today that actually reduce carbon in the air and in the environment. At the Glasgow UN summit, which I know a lot of us had the opportunity to go and to talk about, there's a recognition that carbon capture and some of these other technologies are a few years behind the expectation amount around direct emission reductions. But it's no less important to have a parallel approach, parallel strategy, and we need the regulatory environment that embraces that innovation. And that means the public policy and the private sector partnerships are essential. Here in Seattle, Washington, where I live, we are the home of Amazon, Microsoft, Starbucks, Boeing, and many others. And all of those companies have embraced public conversation about their role in not just reaching science-based targets directly in terms of their scope 1 and scope 2, but really embracing scope 3 work as well. And that has to include very serious approaches to our global supply chain relative to these types of investments. So I think there's a lot of traction. We know we have to accelerate this work.
Thank you very much. We have a lot of questions already on this technological discussion. Maybe globally, a question on volumes. How much CO2 do we have to store? Maybe we could start by in Europe or in the world to achieve this net zero. Jean-Philippe, maybe you have ideas for Europe?
No, even globally, I think if we refer to there are different trajectory and paths that are and scenarios that are being worked on. And one reference is the International Energy Agency and its recent report on the net zero. And I think there, what is mentioned is volumes in the order of magnitude of 7 billion tons of CO2 being captured and stored annually by 2050 to keep a net zero trajectory. Just for the sake of comparison, today worldwide we are capturing and storing around 60 million tons per year. So if I look at Northern Lights, like I said, we are designed for 1.5 million tons per annum. We can increase, expand up to 5. That's one Northern Lights project per week in the next 30 years. That is the ambition, and that is actually our duty.
That's really that puts into perspective what has been done and what still has to be done. Helen, what are the ambition of direct air capture?
Yeah, and moving on from Jean-Philippe's global view, if you look at the European Commission's climate neutrality scenario, by 2050, over 200 million tons a year will be captured through direct air capture alone. That doesn't include, Jean-Philippe will be working with those industrial emissions that are captured. That's purely what we call direct air capture. And that atmospheric carbon can be permanently stored, can be made into fuels, can be used in products. So it's a whole new marketplace. And what we saw yesterday with the European Commission at a big conference about sustainable carbon, a big wish there to move from fossil carbon to sustainable carbon. How do we create these sustainable carbon cycles, given that we know that's the way we want to go with net zero and climate neutrality? Thank you.
Thank you. We have other questions on economical side, so more about business models. So we'll address them a bit later. Maybe a last question on the technological side. What type of cost would be required to store CO2 for a company with emission of 30,000?
Looks like we lost. Oh, there we go.
We lost Sébastien.
We lost Sébastien, yes.
I hope someone can stand in to his chairperson role.
There we go again.
Thanks, François. I think François might be there. Thank you.
Come back, but we need Sébastien to go on. I think he will reconnect.
I think while he's reconnecting, I think he was mentioning a question on the chat related to the cost of CO2, the cost to store CO2 for a company with emissions of 30,000 tons per year. Is this too small or to make sense? on our side, at least on Northern Lights side, we try and address, of course, all emissions from industrials. But there is a minimum scale, of course, to go after a full carbon capture, transportation, and storage value chain. I would say the bigger the better, in a sense, thanks to scale-up effect. That's how we can drive costs further down. But there are innovative solutions to think about, and I think their technology will also help us to reduce costs further. That is a key trajectory.
I think it depends on how concentrated that CO2 stream is. So if you're looking at direct air capture, we have a not very CO2 concentrated flow because we're capturing it from the air, which is obviously more expensive than flue capture. And obviously, if you're looking as a company with 30,000 tons, you can always look to third-party providers of permanent carbon removal if that is something you want to look at. And the marketplace is alive with that. We've seen Stripe, Microsoft, Swiss Re, all those buyers buying that permanent technical removal because they aren't energy intensive and they can't capture their own emissions.
There was, as we welcome Sébastien back, there was one question in the chat that I wanted to address directly, if I might. Very thoughtful question about whether carbon capture is really allowing the incentives around non-renewable resources around Saudi Arabia and other examples around the world, and whether it sort of allows us to continue in a pathway. I think that's a very fair question. It's a strategic issue on the table facing all of us at the policy and the business level. And I just want to say very directly that I think it is absolutely essential that we recognize that we cannot be successful without both strategies at full force. We cannot in any way allow it to supplant direct emission reductions in any way. But the policy framework needs to also embrace the work very forcefully of both. Like, we need both sides. I just can't stress enough that I think that the traction in Glasgow, the conversation was a little uncomfortable at times about this issue. And there was a lot of worry that to define and achieve carbon neutrality as a country, that there would be a consideration, and it opens the whole conversation around offsets. I mention it because on the West Coast of the United States, California, and now Washington State is adopting a carbon pricing scheme around cap and invest, a carbon pricing at an economy-wide level. And British Columbia in Canada also has a carbon tax. So the traction in the Pacific coast of the US and Canada is around meaningful carbon pricing. So there's no attempt whatsoever to avoid direct emission reductions. But I just really appreciate that very important and strategic question.
Thank you, Irvin. Maybe we can continue with the other kinds of levers, which are the regulatory and policy levers. These are, of course, crucial ones for emerging industries, as we're talking about. So, Jean-Philippe, you talked a little bit before about the European Commission help. In general, what about the regulatory framework on CCS? Is it stable enough? Are you expecting major policy breakthroughs?
So I think that the regulatory framework is evolving and strengthening rapidly to underpin future investments in CCS. If we look a bit further in the past, since the Paris Agreement and subsequently the announcements of net zero ambitions a bit everywhere in the world, we have seen the emergence and strengthening of supportive policies, typically incentivizing investments through various funding schemes. So national schemes in Europe, in different states. You mentioned the Commission Innovation Fund, but also CEF are key instruments. Tax breaks. There is the 45Q tax credit in the US that allows to launch numerous CCS and carbon removal projects. You have carbon pricing with ETS in Europe, but also now in China, for example, and combination of the three, of course. For me, the regulatory framework is strengthening. And when it comes to Northern Lights, since we are now preparing for our startup and operations, there are still some regulatory aspects that need to be sorted out, like the granting of an injection permit, or even state-to-state bilateral agreements regulating the export of CO2 for offshore geological storage. So we are working hand in hand with the Norwegian authorities to progress on those matters. And here again, we are first of our kind. We are inventing by doing.
And this will be bilateral agreements. This will not be included in, I don't know, a European or a worldwide regulatory framework for CO2 exchanges?
So there is the London Protocol, and that is an international protocol regulating the transboundary export of CO2. And those state-to-state bilateral agreements are a temporary measure to make sure we can develop those projects while the London Protocol still needs to be ratified officially.
Helen, same question for direct air capture. Are there policy successes you are looking for in the coming years?
I'll go to America first. So the 1 million ton plant we have planned with our partners 1.5, which they will hopefully start building this year, that is supported through the policy framework there. So as Jean-Philippe mentioned, it's the tax credit from the 45Q, but that's also stackable with the Californian low carbon fuel standard, which recognizes direct air capture into storage as a mitigation option. So there we're not going to the classic carbon pricing, we're going to road transport policy, which does have an implicit carbon price. And that's the reason why we can bring that size of that project and do that build, basically start that this year. And if we transfer that over to the EU specifically, where I work, I think there's 5 elements that we ask for any framework. That's, first of all, set a target for technological removals. And we've seen an aspirational objective of 5 megatons by 2030 for the EU. Then the most important thing, and I hope Reuben will come back on this point as well, is robust certification. That license to operate, we need to have the monitoring, reporting, the verification, the accounting, so that what is taken from the atmosphere is permanently stored. And without that certification, we can't go any further. And we know the EU will legislate at the end of this year, and that's really important to work on that as an industry. We also need the open access or the open source transportation infrastructure and storage for CO2, like Northern Lights. Without that, we're just one part of the puzzle. We can't deliver negative emissions with all our partners on the supply chain. We need those support for those first of a kind plants to learn by doing and pay down the cost curve. And then eventually, once we have that license to operate, we need to think through how will the emissions trading system, for example, how will that get to net zero and not just zero like it is currently designed to do? So there'll be some change to the regulatory framework, but not until we've gained that trust from that robust certification that we're delivering what we're saying we're delivering. Thank you.
Thank you.
So,
yes, Reuben, please.
Thank you. Yeah, well, I would say that I think there is an accelerated alignment around evidence-based best practices that the United States is looking at for the first time relative to the thought leadership, not just in the Nordics and the EU, but really worldwide, relative to the certification process, the accounting, the transport, the siting of facilities. There's a much more aggressive recognition of the United States' particular failure in many of these areas and our lack of leadership. I would also endorse the concept that the the policy framework of both carbon pricing, which I talked about a little bit, and the low carbon fuel standard as a way to reach parity of cost is very important. And in the United States, in California, Oregon, Washington, and British Columbia, the low carbon fuel standard is being implemented in all of those jurisdictions. And so we have an interconnected, interoperable market that is, of course, extraordinary in size and scope. And we're seeing the development, particularly if I could just pivot briefly to renewable hydrogen. And we're seeing a radical exploration of that in our market. And I think that's a sort of a symbolic representation of the decarbonization strategy for aviation, maritime, energy storage, and a few other sectors. So we're seeing alignment from a policy point of view, but I think you're going to see an accelerated time frame that the United States has been particularly unsuccessful at previously will change in the next year or two.
Thank you. I see lots of questions about technical aspects. So maybe because of what you just said before, Helen, about delivering what was promised. How do we know today that carbon, either through CCS or through DAC, does not come back into the atmosphere? How are we sure about that?
Yeah, so I'll talk about the EU where I have more experience, and then I'll pass that one to Jean-Philippe. But first of all, we have the EU CCS directive. What is the CCS directive there for? Well, it's there for the monitoring, reporting, verification of CO2, which is transported via pipeline and stored underground. And that framework was set up in the sort of late 2000s, before 2010, to really put in the whole regulatory framework about how you safely store CO2 and what happens. So if it was to leak, which I don't think it would do because you're monitoring it and it's safely underground 2,000 meters, then there are significant certain consequences. But that's not my area of expertise. I'm not a storage operator. So I'll pass to Jean-Philippe for a more informed response.
Thank you, Hélène. Yes, I can take that one, of course. So I think there are two questions behind. First is indeed how safe the CO2 storage is, and then how do we ensure it is safe and permanently stored. So on the safety, I think that storing CO2 underground is using a similar natural process that has actually trapped CO2, oil, and gas for millions of years. So you have two kind of fields: oil and gas depleted fields. You have saline aquifers, but they have all the same key geological features that is required similarly for CO2 storage. A layer of porous rock to absorb the liquid CO2, and then on top of that, an impermeable layer of caprock to seal this porous layer underneath. That is what we call a storage complex: the reservoir and the caprock on top of it. Inside this porous rock, inside the reservoir, there are three natural trapping methods which are making the safety of the CO2 storage. And that is increasing over time. There is the injected CO2 that will be trapped in the pore of the rock and will be stable because kept under pressure. Then you have a dissolution trapping, so a process where a portion of the CO2 is dissolving in the surrounding water. And then you have mineral trapping. So over time, some of the heavy CO2 water will sink to the bottom and may react to form minerals. So that is what's happening in the reservoir deep down underground. And then how do we ensure the safety is, of course, we are continuously monitoring through using different technologies and at different reservoirs lifetime. So taking picture to make sure that the CO2 is stable and permanently stored.
And about the scalability of this solution, you mentioned before that it could be up to one project, one Northern Lights per week. Do we have an idea of the potential in terms of storage that we have? Is this technology scalable enough, and do we have potential enough for it to be really relevant for our Path Zero?
So one thing is that we are unfortunately not short of CO2. So CO2 is there, but we are not short of storage capacity neither. And that's the good part of it. So you have different areas worldwide with sedimental basins that are suitable for storage, CO2 storage. The North Sea region is one of them, but you could also look in America, in the US, Gulf of Mexico, you have the Middle East. So different areas where storage capacity are quite important.
Another issue that is often raised is the global ecological result of CCS and of DAC. We already talked a little bit about it, but detractors say that investing in these breakthrough technological levers will not motivate heavy industries to activate the other kind of levers: energy efficiency, greener fuel, and of course sobriety. I suppose you have there have been modelizations or studies about that. Maybe Jean-Philippe first, what do you say about the global ecological result of such a project in terms of construction, in terms of life cycle assessment?
So let's start with the end of the value chain, and I think Hélène will take the beginning, since she's on the capture side, and then we do the transport storage. On the transport and storage, where we will emit CO2 is first on the shipping leg. Today we are building CO2 ships, CO2 carriers that are fueled with LNG. So even though that is a low emission fuel, it's still emitting. So those ships will emit, and then we have this terminal where the ships will offload, and we need to energize the terminal, run some pumps. All in all, there is Gaznova, that is a Norwegian state storage company for carbon, so carbon capture and storage, that has published a report with a life cycle analysis. And on the transport and storage side that we are developing, basically we, at the end of our license to operate, so namely 25 years, we will have emitted a bit less than 4% of the CO2 that we intend to store. So that is the result of the study. And of course, what we will do is put in place measures to reduce that further. And when it comes to ship, the next generation of ship, we have innovation and technological breakthrough to come to either capture CO2 being emitted while on board, or even go for zero carbon ships. That's the next step.
Thank you. Helen?
I think along the same lines, we are an energy intensive process. So we need clean electricity to run the air contactors, which is this big fan which sucks the air through the structure where you trickle down the liquid, which captures the CO2. And then everything we're doing after that is concentrating the carbon dioxide to then release it. And obviously there's temperature involved in that. So we call for a robust life cycle assessment of our impact, recognizing that we do use energy, and energy can come from different sources, because we need to be completely transparent in our impact. And I don't have a problem with that. And there'll be different pathways and different energy intensiveness of direct air capture. But again, back to that robust certification, clear life cycle assessment, that's that whole transparency piece which needs to be right, and it's the role of the policymakers to bring that in to make sure we can all comply with what is required back to the social license to operate. Thank you.
Thank you. Reuven, has there been political discussions about the relevance of the ecological results of carbon capture in the latest Glasgow discussions?
Yes, I think so. There's no question that there's a desire for it to be successful, but one of the questions in the chat is very important, which is enough being done to inform the public and political stakeholders about the new technology, or is the industry ahead of it? And I think the answer is no, and that not enough is being done. I think that there's a deep sense of discomfort about the development of an approach that feels like it might be an excuse to avoid direct reductions. And I'll give a specific example. In our state here in Washington State, we have about 120 large-scale industrial entities, aluminum smelters, manufacturing, food processing, airplane manufacturing, and many others that are covered by our economy-wide carbon pricing mechanism now that will begin next year in an attempt to link with the state of California and the province of Quebec in the Western Climate Initiative. The obligation of those industrial players to decarbonize means that in effect in Washington State, we've gone from 100 million metric tons in this last year to 5 million metric tons by 2050. So the direct emission reduction obligations are astronomical and very, very challenging. So I think that having a parallel strategy, as we've discussed, about the opportunities for CCUS is particularly important to show that it is aligned with this policy and the utilization, again, of the clean fuel standard, the consistency that we talked about, of policy framework between low carbon fuel standard and others is essential, and the accounting and certification that Helen has talked about. We need to do more. We're at some degree of risk by not educating policymakers of the role and the uniqueness of this opportunity. And I think we know that we're on the edge of it being a technological project, but whether the economics of it work out, if the policy framework is not there, is a problem. So we have a lot of work to do.
To answer also the questions on utilization, I think it's a little bit like what Reuven just said. It's not an either or question about carbon storage or carbon utilization. It's really and, meaning that I think there is a 10% potential for carbon utilization. So that leaves 90% for storage. So I think we shouldn't oppose carbon utilization and carbon storage. It's really the same industrial ecosystem. Maybe we could go up to the financial levers to continue this exchange. So always the same goal, to enable the quick maturity of the carbon industry. What are the financial levers that could be activated precisely? Are the prices of your solutions prohibitive today? What are your business models? And are you expecting a major shift in this business model in the coming years? As usual, we will begin with Jean-Philippe.
I was getting prepared. Yeah, I think more financial levers are key, indeed, when it comes to launching a new industry. And in that sense, Northern Lights could only be developed and taken FID on 2 years ago, only through the cooperation between government and companies. The Norwegian state is covering a significant proportion of the development and operational costs for the first 10 years of our project. And in return, Northern Lights will take a delivery of and serve 2 Norwegian capture plants free of charge. So again, against subsidies, we serve 2 Norwegian capture plants free of charge. And then on top of that, we have spare capacity that we are trying currently to sell to third-party customers. So our business model is solely relying upon the selling of our services to industrial customers. I have seen in the chat some questions around can we retrieve more oil or gas from underground by injecting CO2? That is a technology called EOR, enhanced oil recovery. We are not at all into that business. Our business is to sell a service to industrial willing to decarbonize themselves. And against that service, we charge a fee. So today we are, as I said, in quite advanced tariff discussions with customers and evaluating in a competitive market and with other projects around. So I cannot give a range at this point of time. What we need is to offer a customer a tariff that is competitive with the alternative decarbonization measure. And the tariff is actually depending also on factors such as the volume, the transport distance, the contract duration, flexibility, and so on. So it's varying depending on the customer. What we see directly is that the cost of the full CCS value chain, so that includes capture, transport, and storage, is in most cases still higher than the current CO2 price level. So it's more expensive for an industrial today to emit to the atmosphere rather than to go to the CCS direction. And that is why first movers need access to public funding. That is really unlocking those first projects. In the longer term, I expect that both the costs of development and execution of those CCS projects will go down, and at the same time, the cost for an industrial to emit CO2 will go up. And that will enable the realization of CCS projects without subsidies. And recently, I think the increase of the ETS quota price in Europe, flirting around 90 euro per ton today, is a concrete step into that direction. On the cost side, I think that realistically we can expect a decrease by 20 to 25% over the next 2 decades, because the build out of projects will lead to streamlining of design, execution, modularization, competition in the supply chain as well. But also the shift from an investment for individual project to CCS hubs will be a game changer. Multi-industry hubs will deliver huge economies of scale, and that will reduce costs, I would suppose, by as much as 25%.
And in which time horizon?
So hubs are being created right now. There are discussions around hubs in Europe ongoing. And the D'Artagnan project in Dunkirk is a very good example. Antwerp at Sea in the port of Antwerp. You have on the port of Rotterdam as well, portos. So for me, hubs will dominate the CCS landscape beyond 2025, 2030. So it's coming very shortly.
Thank you. Helen, about the financial model of direct air capture. Same question, are you expecting a major shift in the coming years?
Yeah, just to answer some of the questions about costs that you've got in the chat. So we've published a peer-reviewed paper in the academic journal Joule, which talks about our costs for direct air capture. And though that publication there, which I can post in the chat a bit later, talks about the costs coming down to below $100 a ton of CO2. Obviously, there's a range within that. It goes from 240 down to below around 90. And that's our ultimate goal, is to scale direct air capture at least cost. And so what we're looking at, we talked a bit about the business case in America, where we can stack the 45Q and the Californian low carbon standard, which starts to close that business case for investment. And what we're looking at in Europe is there a similar way we can stack the policy framework? Now, we do have a lot of interest from the voluntary markets, and that's where you might see a lot of noise about it being sold out. There's not enough carbon removal. Well, that's because a lot of the times the companies want to buy carbon removal, technical carbon removal that's happening now when we're not yet operational. So you can pre-purchase that carbon removal starting at around $300 a ton of CO2. But obviously, as Jean-Philippe has just said, the carbon price is around 90 euros, so we've got a big gap, especially in Europe. Europe has got expensive energy prices. We need to think through the CO2 transportation and storage costs as well. So how do we create that policy framework? And I talked a bit about that. How do we build that case? How do we get that support for those first-of-a-kind plants? We don't know yet. All our plants that are in planning, both from a storage perspective or a fuels perspective, we are having to negotiate with governments about if we can make this viable. What I will say is America, is so much excitement happening over there. The concept of DAC hubs is really growing. The amount of money that's coming forward to recognize that industrial advantage, that growth strategy, is very exciting as well. So I would ask Europe to look outside of its boundaries and look at what the world is doing on carbon removal. And the final point I'd like to make, because we are more expensive than emissions reduction, means that emissions reduction should go first. And so that in any levers and policy framework that you're building, you might have a separate pillar for removals, but don't forget, in economics and business sense, companies are going to do emissions reductions first because we are more expensive. Yeah, I'll end there. Thank you.
If I might, I did. If I might, I think first of all, just as a side note, here in Seattle, we're the home of the Gates Foundation and Breakthrough Energy. And the categories that Breakthrough Energy and Bill Gates have prioritized in terms of their innovation investments are first, direct air capture, second, renewable hydrogen, long duration energy storage, and sustainable aviation fuels. So that is the investment traction as broad categories at a strategic level that really have momentum. I would note also, I think from a public policy point of view, that some of the direct air capture and other experiments around the country, there has been a partnership from public investments on the capital side. So I think that the balance here is that there's a capital investment opportunity for public partnership if that allows the operating costs and the production and the distribution costs to be closer to parity. And then finally, we have to state the obvious, which is there is a massive movement, certainly here in the US, but of course we know worldwide, relative to acknowledging the negative externalities of the massive fossil fuel investment subsidies that we have in our system. Here in the US, we have massive subsidies embedded in our ecosystem, top to bottom. And gasoline right now is at a high, and it's maybe $4.40 for a US gallon. So, you know, there is a dramatic change happening relative to investment in innovation. And I think that the capital expenditure is the opportunity for public investment. And that's where the low carbon fuel standard is expanding to other states in the US. So it's not just a California policy anymore.
Thank you. Another point that was made was about the localization of the factories, direct air capture factories, for example. Is the system only viable where green electricity is available and cheap, or is the system also would it also be viable in the US or in France?
I assume that's for me. So you can take CO2 out in the atmosphere anywhere. As you well know, CO2 is in the atmosphere. But obviously you want to do it where it makes sense. So our partners, Carbon Removal, are looking at a site very close to Northern Lights where that storage goes offshore, because that would limit your transportation. And also you would have clean electricity. So you want to be sensible about where you choose your location. Obviously, climatic conditions go into that as well, but you can do it anywhere. It's just that the cost will probably vary depending on your input, which is your energy costs. And also, let's not forget, and a lot of the chat here is around social license to operate. Where is it that this is welcomed? Have we informed the public? I think that's very, very valid. I'm talking to you about it from my direct air capture bubble, but fully recognizing that most of the time when I speak to policymakers, they haven't heard about what we're doing. And we really need to think through how to sensibly talk about the role that direct air capture can play, because what I want to make clear is it's not the only tool. It's one tool in the toolbox that we have to reach net zero. Thank you.
That tool would be ecologically beneficial, even if the assets are not localized in Iceland or in places where there is green electricity.
You would need green electricity, otherwise you would have to watch for your carbon footprint. So if you were to use electricity that wasn't clean, the carbon footprint of what you're doing goes up. So ideally, we wouldn't be looking to do it where the electricity is not clean.
Okay, thank you. Maybe you have something to add about applications of your technology. Maybe we have been talking about cement, steel, really heavy industries, but in maybe not so near future, would these technological solutions also be viable for other kind of industries, maybe not so heavy industries? Jean-Philippe, maybe you could. Yeah.
Yes, I can take that one. So what we try to address is indeed to permanently store CO2 emissions that are irreducible. So the very hard to abate industrial sectors. You mentioned cement, steel. You also have refineries, waste to energy plants. So that is one aspect, is to decarbonize really the hard to abate sectors. Other aspect is enable the CO2 removal from the atmosphere. So namely what Helen is doing with carbon engineering. Because ultimately, once you capture CO2 from the air, you need to store it permanently somewhere. And third, you have as well as a lever the possibility to develop a blue hydrogen. So CO2 captured in the process of steam methane reforming, thereby leading to the production of blue hydrogen and decarbonized hydrogen. So that is the third levers we target as well.
And Helen, for direct air capture, your clients, of course, can be of any industry, but as the price, as you reminded us, is higher than simply emitting. Who are you targeting for clients, maybe in the near future and the not so near future?
Yeah, the price is higher than emissions reductions. So, I mean, lots of this commercially confidential. So we're a technology provider. We're partnering with plant developers around the world. Who's mainly interested in what we're doing? So we can take CO2 and we can store it through the networks that Jean-Philippe is developing, or we can take that atmospheric carbon and combine it with clean hydrogen and make fuels. And that's where the aviation sector is really excited about what we're doing. So I would say we sit both in the negative emissions in those really progressive corporates who want to meet those net zero targets by 2030, and also with the aviation market. But as you say, that role for removals, what is the residual emissions that we can't get rid of or it's too expensive, and where would it fit with to have technological removals? And that whole political discussion has not been really bottomed out. We've seen all these scenarios, IEA, IPCC, from the EU Commission, from the US, but it's still, again, this discussion that we're having. We're not ready yet. Emissions reductions first. Can you come back later? But the point, I mean, back to Jean-Philippe's point about the scale, if you start to scale now and learn by doing, then you'll get the scale that you need to meet those net zero targets. If you delay, you risk pushing that back, making it more expensive. And so that's why you hear us calling for, let's do those first plants this decade, and then we can scale when we're really needed in the 2030s and 40s. Thank you.
Thanks.
Yes, I might say that I really appreciate that comment, Helen. I think that that goes to the core of the need for public policy traction in this area to embrace this work, because you know, assuming that the very difficult to decarbonize sectors and the opportunities in aviation and some of the other application categories is successful at scale, as we've talked today, there really is a recognition that the public elements of this will catch up. So we have to build the framework. It's a market traction that needs to be supportive. The private investments like Breakthrough Energy and others are going in this direction. And I think educating folks about the importance of this is really an important piece of getting traction. And one other comment that you made, which is the full life cycle analysis, because the value proposition really shines when the full life cycle analysis is incorporated in the calculation.
Thank you. The time flies, so I think we'll have to conclude for today. As we heard today, there is still a lot that has to be done, particularly on policy and financial aspects, to ensure a quick maturity for the carbon industries. We've seen that heavy industries are implementing decarbonization strategies at their own level, but they now need the emergence of what we just talked about, so an industrial decarbonization ecosystem that includes carbon capture and recovery or storage in order to eventually achieve the neutrality that is required of them. And I think we can also add that the current challenges of further decarbonizing the industry has to be set against the social and economic challenges, especially the challenges of reindustrialization in Western countries, because it also allows the development of new sectors and the creation of non-relocatable jobs. So this is also an issue of economic development and circular economy. I will end by saying this. I would like to thank very much our three speakers for their time and expertise, as well as the Nextcontinent and Eurogroup organization. Feel free to go on asking questions by email and to contact us, of course, for further discussion. I wish you a very good evening or afternoon for some of us. Thank you. Bye.
Thank you. Bye.
Thank you. Thanks so much. Bye-bye.